Welcome back to the deep dive. Today, we are looking specifically at, well, the architecture of the immediate future.
Hmm.
And I don't mean buildings, I mean the digital scaffolding that is holding up the entire AI economy.
It is a fascinating time to be looking at this. We've really moved past the novelty phase of AI.
We really have. We're not just talking about a chatbot writing a haiku anymore or, debugging a few lines of Python. We are talking about the agentic web.
Right.
We're looking at a paper from Google DeepMind published in February 2026, so hot off the press, titled Intelligent AI Delegation. And the authors, Tomashev and the team, they're tackling something that sounds kind of boring on the surface, delegation, but when you dig in, it's actually the Wild West.
It really is, because the shift we are seeing is that AI agents are no longer just doing tasks you give them. They are acting as managers.
As managers.
They are
right.
decomposing complex goals, and then they're going out and hiring other agents, or even humans, to do the work.
Which sounds great until you realize, wait, how do I know who my AI hired? Did they do a good job? And did my AI just pay them with my money?
That is the core tension. The hook here is, how do we prevent this from becoming a massive game of broken telephone? How do we handle trust, money, and safety when machines are hiring machines?
So let's unpack this. The paper talks about intelligent delegation. How is that different from just, I don't know, a computer program running a subroutine? We've had code calling other code since the 70s.
It's a fundamental shift in responsibility. In traditional computing, or even, early AI, you had a human in the loop making all the big calls. You were the conductor.
Okay.
Intelligent delegation defines a process where there is a transfer of authority, responsibility, and accountability.
Okay, give me an analogy.
Think of the difference between, say, a calculator and a project manager. You tell a calculator to add 2 plus 2. It doesn't have a choice. It doesn't think about how to do it. It just executes. That's a tool.
Right.
Now imagine you tell a project manager, organize a conference for 500 people next month. You aren't telling them how to print the badges or which caterer to hire. No, you are saying, I trust you to handle this within these boundaries like budget and time, and I will hold you accountable for the result. That is delegation.
So the AI isn't just a tool anymore.
Yeah.
It's like an employee with decision-making power.
Precisely. And the why behind this paper, the mission, is that current methods are just too brittle. They rely on heuristics, right? Hard-coded rules of thumb. And if the environment changes, say an API goes down, or the price of compute spikes, the old systems just crash. Real-world deployment in 2026 needs adaptive systems that can handle uncertainty, especially when the stakes are high.
Okay, so let's get into the mechanics. I want to visualize this. Let's say I'm an agent. My user gives me a massive project, say, launch a new podcast. That's huge. How do I even start breaking that down? The paper mentions task decomposition.
And this is where it gets really interesting technically. The authors propose a principle called contract-first decomposition.
Contract first. That sounds like something a lawyer would say.
It does, but it's actually a safety mechanism. It means you should only delegate a task if the outcome is verifiable.
So don't hand off a job if you can't check if it was done right.
Think of it this way. In the old world, you manage people by trusting their process. You hire a designer, you trust they know how to use Photoshop.
Sure.
In this agentic web, you often can't trust the process because it's a black box. You don't know which model is running under the hood.
Yeah.
So you have to ruthlessly verify the output.
Okay.
If you can't write a math equation or a test to prove the job is done, you simply do not delegate it.
Okay, well, let's apply that to the launch a podcast example.
So upload MP3 file to Spotify. Is that verifiable?
I guess so, yeah. You can check the URL and see if the file is there.
Exactly. So the agent can delegate that. But what about design cool cover art?
Ooh, that feels subjective. Cool is hard to measure with math.
That's the catch.
Yeah.
If the AI delegates design cool art to another AI, how does it know if the result is good?
It can't.
It can't. So the agent hits a wall, and this leads to the make versus buy decision.
Make versus buy.
The system has to decide, do I do this myself? Do I hire another AI agent because it's cheap and fast? Or does this subtask need a human?
Ah, so this is where I come in. The AI realizes I can't judge cool, so I need to hire a human to approve the art.
Correct. That's the criticality or subjectivity check. The AI outsources the art judgment to a human on a marketplace, but it keeps the MP3 uploading for itself or for a cheaper bot.
Okay, so once the agent has broken the task down, it knows what it needs, it has to go shopping. The paper describes a shift from centralized registries to decentralized market hubs.
Yeah, think of it like a stock market for tasks. Agents don't just pick a name from a phone book. They put tasks out for bidding.
So my agent says, who wants to transcribe this audio file? And a bunch of other agents start shouting prices.
Essentially. And this is where we get into multi-objective optimization.
Whoa, slow down. That's a mouthful.
It's just a fancy way of saying you really want just one thing. You aren't just looking for the cheapest agent. You're balancing competing objectives. Cost versus speed. Privacy versus context.
Oh, the privacy one is huge because giving an agent more context like, here are all my previous emails so you can mimic my writing style, that might help them work better, but it really increases the risk of a leak.
That's the trade-off.
Yeah.
Imagine a mixing board in a recording studio. You have a slider for speed, a slider for cost, and a slider for privacy.
Yeah.
If you push the privacy slider up, meaning you share less data, the quality slider might go down because the agent is working blind.
So the delegator agent is constantly tweaking these sliders in real time.
Yes. It's looking for Pareto optimality.
Right.
That sweet spot where you can't improve one metric, like speed, without hurting another, like cost. It's a constant, lightning-fast negotiation.
Okay, so my agent hires another agent. Now we have the trust problem. The paper calls it the principal agent problem.
The classic economic dilemma. When you hire someone, their incentives might not align with yours.
Right.
Maybe they want to save compute power, so they give you a half-baked answer. Or they want to maximize profit, so they overcharge you.
But hold on. We already have reputation systems. Uber has stars. eBay has ratings. Why doesn't that work here? Why do we need this immutable ledger the paper talks about?
Because on Uber, you are a verified human with a driver's license. In the agentic web, an agent is just code.
Okay.
If an agent gets a bad rating, it can just delete itself, spin up a new identity with a new cryptographic key, and start fresh with a clean slate.
The fly-by-night contractor problem.
Exactly. So the paper argues reputation needs to be a portfolio of verifiable credentials, like a digital badge that says, certified for medical translation by third-party X.
Right.
And crucially, that history is recorded on an immutable ledger.
Blockchain.
In essence, yes. A record of past performance that cannot be faked or deleted. If an agent failed a task 3 months ago, that failure is on the permanent record. You can't just ghost the system and come back as a new person.
That's intense. It's like a permanent credit score for robots.
But what if the data is super sensitive? The paper had this section on privacy technologies that blew my mind a little. Zero-knowledge proofs, or ZK snarks. This is a game changer for delegation. Imagine I need you to analyze my medical records to find a diagnosis, but I don't want you to actually see my name or the raw data.
How can you analyze it if you can't see it? That sounds impossible.
It does, doesn't it? Let's use an analogy.
Yeah.
Think of Where's Waldo?
Okay, the picture book.
Imagine I want to prove to you that I found Waldo, but I don't want to show you where he is because maybe I want to sell you the solution later.
Okay, so how do you prove you found him without pointing at him?
I take a giant piece of cardboard with a tiny hole cut in the middle. I place it over the book so that only Waldo is visible through the hole. I show you the hole. You see Waldo. You know I found him. But you have no idea where on the page he is because the cardboard covers the context.
I see. So I get the verification Waldo exists, but I don't get the location data.
Exactly. In the AI world, the book is your medical history. The agent proves it ran the calculation correctly. It found the diagnosis without ever revealing the page or the raw data to the verifier.
So I get the result, and I get a mathematical guarantee that the result came from my data, but the agent never saw the data in a way that could be leaked.
That's it. It enables trustless delegation. I don't need to trust you as an entity. I just need to trust the math.
That solves the direct link. But what about the chain? You mentioned earlier that agents hire agents who hire agents. The paper calls this transitive monitoring.
This is the subcontractor problem. If Agent A hires Agent B, and Agent B outsources to Agent C, Agent A usually has no idea Agent C even exists.
Right. It's like when you hire a general contractor to redo your kitchen and suddenly some guy you've never met is in your house installing the sink.
Exactly.
If the pipe busts, who do you blame?
In this framework, Agent A doesn't try to monitor Agent C directly. That just doesn't scale. Instead, Agent A monitors Agent B's ability to monitor Agent C.
It's like recursive management. I'm checking your homework on checking someone else's homework.
You verify the verification process.
Yeah. But let's be real. Even with all this math and cardboard cutouts, things go wrong. The internet goes down, servers crash. The paper talks about adaptive coordination.
This is the reality of failure. The environment is dynamic, so you need an adaptive response cycle. You monitor, you detect an issue, you diagnose, you respond. But the key insight here is how the system decides to respond. The paper highlights the concept of reversibility.
This was one of my favorite takeaways. It's a decision filter.
Yes. If a subtask fails, say an agent tried to book a flight and the payment failed, is that reversible?
Yeah, usually. You just try again or book a different flight.
Exactly. So the agent can auto-redelegate,
Hmm.
maybe pay a backup agent a bit more to get it done instantly. But what if the action is irreversible?
Like deleting a database.
Or transferring your life savings to a weird crypto wallet?
Right. You can't Z that.
Then the system must trigger an immediate termination or human escalation. You simply cannot automate the recovery of an irreversible catastrophe.
And that links to liability fire breaks, which sounds like a legal term, but it's actually code.
It's both. Contracts need defined stops. Points where liability doesn't pass further down the chain. The paper suggests agents might have to stake funds in escrow.
Put money on the table.
Put money on the table before they take a job.
Like a security deposit.
Exactly. If the agent messes up, they lose the stake. It forces them to have skin in the game.
I want to pivot to us, the humans, because reading this, I got a little worried about our role in all of this. The paper mentions the zone of indifference.
This is a psychological risk and a very real one. The zone of indifference is a concept from management theory. It's the range of instructions a person will execute without critical thought.
It sounds like fancy talk for being lazy.
It's not just laziness, it's conditioning.
Yeah.
I mean, think about how many terms of service agreements you've clicked agree on in your life.
Oh, man.
Have you read any of them?
Zero. Absolutely zero. I just want to get to the app.
Now imagine your boss is an AI. It sends you 1,000 approvals a day. Approve budget, approve email, approve hire. You click yes, yes, yes. Then suddenly, approve deploying code update. Your brain is already in the rhythm. You click yes.
And 5 minutes later, the servers melt down.
Precisely. And here is the danger. Because you clicked yes, the AI is technically off the hook.
I become the moral crumple zone.
That term comes from researcher Madeline Eilish. Just like the crumple zone in a car is designed to squash to save the passenger, the human is kept in the loop just to get squashed by the liability when the algorithm fails.
We had a human operator.
Yeah. But the operator was clicking yes on autopilot because the system trained them to.
So to combat this, the paper suggests engineering cognitive friction.
Making things harder on purpose.
In a way, yes. System interfaces should intentionally make high-stakes approvals harder. Don't just give me a yes button. Make me type out a justification. Make me solve a puzzle related to the task. Force the human to wake up and pay attention. That prevents us from being asleep at the wheel. But there's another long-term risk they mentioned. The paradox of automation.
This is the de-skilling crisis. If AI handles all the routine tasks, drafting emails, basic coding, initial research junior employees never practice the basics.
Right. If I never write a bad first draft, I never learn how to write a good final draft.
Exactly. We end up with a world of senior experts, but no pipeline to replace them. We are burning the ladder behind us.
So what's the fix? Because we aren't going to stop using AI.
The paper proposes something really novel, curriculum-aware task routing.
What you mean?
It means the AI should intentionally delegate tasks to junior humans, not because it's efficient, the AI could do it faster, but to teach them.
That is wild. The AI becomes the mentor. It gives me a task, not to get the job done, but to keep me in my zone of proximal development.
It's necessary. Otherwise, human expertise becomes a finite resource that eventually just runs out.
Let's talk security. Because if I'm a hacker, this agentic web sounds like a playground. The paper lists some scary threats. The confused deputy.
That's a classic. A confused deputy is a good agent that is tricked by a malicious third party into misusing its permissions. The agent has the keys to the castle, and someone tricks it into opening the gate.
And cognitive monoculture. That sounds like a sci-fi disease.
It's a systemic risk.
Yeah.
Imagine if the whole economy runs on agents powered by the same 3 foundation models.
Like, if everyone is using the same version of Gemini or GPT.
Right. If that one model has a blind spot or a bug or a specific jailbreak vulnerability, the entire market crashes at once. It's like planting only one type of banana. One fungus wipes out the whole crop. You need diversity in the ecosystem to have resilience.
So how do we fix this? The paper talks about protocols. They mention existing ones like MCP Model Context Protocol and A2A.
MCP and A2A are the plumbing of today.
And
they connect things. But the paper argues they have a gap. They're good for connection, but bad for safety and finance.
what's missing?
The paper proposes delegation capability tokens. Think of them like macaroons.
Okay, you're making me hungry. Are we talking about the cookie?
We actually are. Well, the technical term comes from the cookie. It's a specific type of digital token. Think of a normal password like a hotel key card.
Right.
If I give it to you, you can open my room anytime, forever, until I change the lock.
Which is risky if I'm hiring a stranger.
A macaroon is like a key card that is programmed to melt. I hand it to you and say, this key works for room 202, but only between 2.0 and 2.15 p.m., and only if you are holding a specific briefcase.
Ah.
The restrictions are baked into the key itself.
So instead of giving the subagent my master key, I give him a key that dissolves in 10 minutes and only opens one drawer.
Exactly. It restricts exactly what a subagent can do. We need these protocols baked into the web layer itself.
So we've covered the mechanics, the trust, the humans, and the security. It really feels like we are growing up. We're moving from the playground, look what this chatbot can do, to the boardroom.
We are. The summary here is that intelligent delegation is about building a constitution for the agentic web. We are moving past the phase of, can AI do this? To, how do we govern the AI doing this?
It's about rules, consequences, and verification.
And the final takeaway is that we are shifting from what can AI do to what should AI do? And most importantly, how do we verify it actually did it?
I want to leave the listeners with one thought from the source material that really stuck with me, and honestly, it gave me a bit of a chill. The paper mentions agentic viruses.
That is a terrifying concept.
These are self-propagating prompts that rewrite themselves to compromise environments. Now, combine that with what we just talked about, delegation.
Right. Agent A tells B to hire someone, B tells C to hire someone.
If an agent delegates the task of delegation itself, recursively, at what point do we lose the ability to even trace the chain of command?
That is the nightmare scenario.
If the virus is the manager and it's hiring other agents, who are we actually working for?
That is the ultimate question of the agentic web. When the chain of command becomes infinite and automated, where does the buck stop?
Something to think about next time you ask your AI to just handle it. Thanks for diving deep with us.
Thank you.
See you next time.